Alright, it's time to go over some of these practice problems. First of all, let's try to take away all of the relevant information from the problem and try to write it down as variables. So we know that the average ACT score is 23. So I'm going to write at the top the mean is 23. We also know that the standard deviation is 3. And we want to know what is the probability that an average gives me a score of greater than 23. Yes, my handwriting is awesome. We want to know if our average is greater than 23.5. And we're going to take a look at n equals 30. Once I've got all of that data, I'm just going to erase this problem since I can just work off of those numbers. First thing I want to do is say, because n is greater than 25, I can use the central limit theorem, which implies that x bar is approximately normally distributed with the center mean and sigma over square root n. So x bar is approximately normally distributed, and now I'm going to write those numbers down with a center of 23. Now the standard deviation changes to 3 over square root 30, which equals a little bit of calculator issues right here, 0.55 approximately, and I rounded that to 2 decimal places. So now I want to know the probability, and I'm going to answer the question now that I've gotten that down. Probability that x bar is greater than 23.5. Going to rewrite that as a z problem, so think back to normal distributions. So this is probability that z is greater than, well, the equation for z is x bar minus mu over the standard deviation of statistic. So the standard deviation here is sigma over square root n. So I'm looking for the probability that z is greater than 23.5 minus 23 over 0.55, which is approximately, got to move this over a little bit. So it's the probability, I'm going to erase this middle part. Z is greater than 0.913. So use your Z table, and let's add one more. Let's get rid of this stuff and figure out that probability. Gonna erase some of this. That's 1 minus the probability that z is less than 0.913. And you use your z-table, look for a z-score of 0.913. That's going to be in the positive half, 0.913. So I'm going to look at 0.8212. That's 1 minus 0.8212. So that's 0.1788. So that is the probability that a group of 30 students, of 30 randomly selected students, score, wow, I'm having troubles writing today, people. My apologies. 23.5 or higher. All right, let's take a look at one more problem. So we're looking at 45% of a community is Democratic. What is the probability that a sample of 100 people is less than half Democrats? So pause your video and answer this question. Alright, assuming you've paused your video, we know that the proportion is 0.45. And we want to know the probability that we get a sample that's less than 0.5 if we take a sample of size n equals 100. So what we need to do is check our values. So we need to check NP. Is that greater than 10? Yes, because 0.45 times 100, let me rewrite that, equals 45, that's greater than 10. And is n 1 minus p greater than 10? Yes. And that's because 100 times 0.55 is 55, which is also greater than 10. So this all means that we can use the central limit theorem. So let's open up another page, rewrite down the information we have. P is 0.45, and we know that p hat is normally distributed with the center of 0.45 and a standard deviation of p 1 minus p over n. Alright? And then we need to figure out the probability we get a p hat less than 0.5. Well, we know that that is the square root of 0.45 times 0.55 over 100. So we're going to quick calculate that. So I threw that in the calculator, I got 0.0497. So we're going to calculate the probability that p hat is less than 0.5, which is the probability that z is less than 0.45 minus 0.5 over 0.0497. Right, that's p hat minus p divided by the standard deviation. So that's the probability that z is less than, let's throw that in the calculator, 0.45 minus 0.5 divided by 0.0497. That's negative 1.01. So the probability that we randomly select 100 people and less than half of them are Democrats, look at the negative 1.01, this is going to happen oh boy, can you spot the mistake here? Look somewhere on this page and spot the mistake. My apologies here. It's the numerator up here. I had it backwards. Instead, that should be 0.5 minus 0.45 over that standard deviation. Then it's the probability that z is less than positive 1.01. So that's all that really changes. And notice when I was looking at the calculator, I realized, or looking at my z table, I realized that 15% doesn't make sense. Because if I have an average of 45% Democrats, you'd expect more than half of that to be, more than half of those samples to be less than 50% Democrat. So now I'm going to look at the correct part, 1.01. That would be 84% of the time. So if you have a community that's 45% Democrat, 84% of the time when you sample 100 people, you'll get less than 50 Democrats, in that group. Sorry this video sort of dragged, but hopefully this was helpful. Take care and look for the next video.